while you're driving.
All right, I think we're on. So again, this is section 9.2 linear regression. This should be, we've actually kind of already ran linear regressions, but I'm going to teach you in 2 parts. Today, I'm just going to go through the notes, and then tomorrow we will do 1 example. Just 1. We will do 1 example tomorrow. Just so you guys know, we will test on Friday of this week over chapter 9. And then, look at this. You know what's crazy, seniors? This is your last regular week. This is your last normal week. Because next week, late starts. Week after that, late starts, and the senior walk and the senior picnic. And then the week after that, exams. Crazy, right? So, like, this is it. This is your last normal week.
Good.
Crazy. See, the funny thing is like, I get like this excited feeling for you guys. Like a lot of you are like, oh no, what am I gonna do with my life? But like, man, I didn't really like high school.
I don't.
You know, like there were a lot of people who like I was okay with never seeing again. You know, like for me, the end of high school was like, oh yes, I only have to see you for 10 more days. You know, like I never have to see you again. Well, no, I just people were mean.
He wakes up and chooses.
Oh, I thought you were saying that like as a teacher.
Oh no. As a kid.
Really confusing.
Like as a senior in high school, like there were a lot of mean people that I graduated.
Yeah.
North Canton sucks.
Well,
So does Lake.
there were nice people, but there were not so nice people too. But I knew, like, you're gonna like keep in touch with the people that you want to keep in touch with. You
There's
know,
only like 10 people that I want to like.
right?
Talk
Like I talked to like 5 people that I graduated with, and one of them is my wife. You know, and that's it. That's right.
Aww.
And I really don't like my 20th reunion is coming up next year because I graduated in 2004. I don't want to go to see anybody. Like I don't really care. Like people are like, oh, you going? It's like, no way.
You ever think about where they end up?
No, don't care. You know.
Like, is there like any like the losers who like look them up on Facebook to see if they're like in jail or something?
Well, you know what's okay. So you know what's weird. You know what's funny is that now, like, so my kids are starting to grow up with kids that I graduated with. Kids. It's like there's this one guy who, when I saw that last name show up on the roster for Sadie's first year class, I was like, are you serious? Because then it's like I'm gonna have to see this guy for 12 more years. You know,
Just
like
move to Alaska.
he's gonna show up at all like the sporting events and all the concerts.
Never let
and,
Sadie leave the house.
I guess not.
No extra
No extracurriculars.
They get sick if they don't leave the
Yeah.
house.
All right. Okay, so let's get to it here. So that's why I have this exciting feeling for you guys. You see, it's like this is it. This is like the rest of your life now.
Appreciate it.
You get to have fun now.
You have to like do stuff.
Yeah, you get to actually like go to a place not the school at 11 in the morning. You know,
Oh.
you can like go to lunch
You're working off the
somewhere
shelf.
if you'd like to. You know, in the middle of September. You know, you can take a trip to Florida
11 a.m.
in March. You know, like do whatever. Well, I guess in February. You know. Crazy. You can like do whatever you want if you have the money for it.
It's gonna be high.
All right, that's the stipulation. Thus, you need a job. Okay, so linear regression, like I talked about in section 9.1 when we studied R values. R value was a way to study how strong things relate with one another, right? As one value increases or decreases, the other value increases or decreases. So now we're going to talk about how do you predict things based off of that. Once you've determined that the linear correlation between 2 variables is significant, and we went through that whole process of determining whether it is significant, we talked about 2 ways to determine if a correlation coefficient was significant. The first way was using that table 11 in Appendix B. The second way was using a hypothesis test. And the hypothesis test is really the way to say, okay, there is to make a statement with some sort of strength saying, okay, there is a positive correlation, a negative correlation, or is there no correlation at all? So once you've determined that the linear correlation between two variables is significant, we then want to find the best line to fit that data, the line of best fit. The difference between the observed y value and the predicted y value is called the residual. The residual. That might be a new word for you. That might not be a new word for you. I know it's actually in my Algebra 1 textbook. Like I'm supposed to talk about residuals, but that word residual I don't use very often. Basically, what a residual is the distance away the y value is, that point is, to the line of best fit. The residual value. That word residual means stuff left over, right? The same word we have for residue. The same thing, residual. Stuff left over. Okay, what's left over? A regression line, also called the line of best fit, is the line for which the sum of the squares of the residuals is at a minimum. What we're going to do tomorrow is hand calculate a linear regression. Okay, we're going to do it by hand without a graphing calculator. You guys probably already know how to do it with a graphing calculator, and that's what today is for, to go through that process one more time. But tomorrow what we're going to do is actually go through the process, find the line of regression, find the R value by taking all of those little calculations that we have. Now, a regression line, by definition, is the sum of the squares of the residuals when it's at their minimum. Okay? Because obviously, if I draw a line of best fit through a scatter plot, the points are hardly ever right on that line, right? The points are hardly ever right on that line. So if the points are not on the line, where does the line actually go? Well, what you're going to do is actually take the distance away those y values are to the line of regression. You're going to square that value. You're going to square the residuals, and then you're going to add them all up. Now, the nice thing is, or the interesting thing here is that you might be thinking, well, if I've got a point above the line and I've got a point below the line, won't these even each other out? If they're eventually going to be, if it's truly in the middle of the data, won't those even out? Yes, that's true. But in the calculation, we take the sum of the squares. So while some distance might be less than or greater than the line, we're going to square those values, and then everything's going to turn out positive. So yeah, they will balance each other out, but what we're going to try to do is make those distances squares a minimum value. A minimum value. So what we're looking at here is the residual is going to be the observed y value minus the predicted y value. The observed y value minus the predicted. And that actual phrase right there, observed minus predicted, is going to come up again and again and again. Not only in chapter 9, but also in chapter 10. Observed minus expected. I'm going to talk about O minus E a lot. Observed minus predicted. Observed minus expected. All right, so how do we actually calculate the line of best fit? Right. I think the arrow got cut off a little bit. The equation of a regression line for an independent variable x and a dependent variable y is equivalent to y equals mx plus b. And notice the notation here. That's called y hat. I know that seems funny to say. Y hat. Okay. You know how we have like x bar? Because there's a bar on the top? It's called y hat. I know, it seems weird. But it's called y hat. There are other things that we actually don't talk about in this course. Like if you take a Stats 2 class, you might talk about it. Like this is called p hat. This is called q hat. There are different things that you might study, again, in like Stats 2 if you decide to take that in college, where, the p value is like the percent chance something happening, and the q value is the percent chance that thing's not going to happen. And you can actually run hypothesis testing on p hat and q hat. because we call p hat and q hat like the population probability that it's going to happen, not necessarily the sample probability that something has happened, but the population probability that has happened. Okay, but that's just another term. That's just another symbol there. Y hat is equal to mx plus b, and it kind of stands for like a population of that thing. That's why when I talk about y hat equals mx plus b, that's basically like saying, okay, in general, if I'm talking about the entire population, if I want to choose to make predictions about the future or about the data, then I can use y hat. It's not the exact equation, it's just the predicted equation. Now, where do those values come from? And this is what we will do tomorrow. How does the calculator actually? Oh, sorry, is that Maggie? Sorry. Thank you. I get it.
Thank you.
Thank you. Where do those M and those B's comes from? Like, where does the M and the B come from? Well, the M and the B comes from. Okay, take a look here. N, sum of x, y's, minus the sum of x times the sum of y, divided by the sum of the x squareds minus the sum of x squareds. Okay? That's what your slope is eventually going to be. That's what your slope is eventually going to be. And the b value is basically taking the, now this is actually an interesting calculation here. How else could I describe this? How in words could I describe that calculation? Sum of the y's divided by n, right? Okay, what's another way I could talk about that? The sum of the y values divided by n. The sum of the y values divided by how many y values I had. The mean y. Yeah, the average y value. Okay, so to find the y-intercept, what you're actually doing is just finding the b value, just like you would find the b value way back in Algebra 1. Finding the b value with your average y value and your average x value. So you take your b value by saying, okay, you take your average y subtracted by m times your average x, which really, y equals mx plus b. If I solve this for b, isn't that y minus mx is equal to b? So really, this is the calculation that you're using. Y bar minus mx bar. That's going to tell you your b value. That's just the calculation for it. Sum of the y's divided by n, sum of the x's divided by n. And again, we'll do all of this tomorrow. I'll show you how to do it in your calculator today. Just appreciate what your calculator is doing for you. Find the equation of the regression line for the gross domestic product of carbon dioxide emissions now. Okay, let's take out our calculators. Let's run the line of regression and in turn also find the R value. Okay, I'm going to go to Stat Edit and I'm going to clear out my lists. And in that list, one, I'm going to input the GDP. 1.8, 3, like I've got 10 pieces of data, is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. We spot check a couple of the lows, 3.9, 2.1, 0.9, 1.43, 4.6. Okay, that looks good enough. 604.4. Okay. We just go through 742.
You messed up the 41.
Oh, 441. It always, the calculator never likes the double numbers. Like it seems to get caught up. Yeah, there we go. Thanks for catching it.
No problem.
262.3. Glad you're here today. 232, 340.5. I'm just going to go back up and just check the rest of those too. 604.4, 432. 434. Okay. 370.4, 742. Okay, cool. All right. So now, again, I go back out to my home screen. I'm just going to stat, calc, and run my linear regression. AX plus B. So there's my linear regression. Now, I guess before I even, ignore that, don't look. What should I predict? Or I'm not saying that. What can I think about in terms of GDP and CO2 emissions? Right. This looks like gross domestic product. Maybe this is like countries with their GDP, right, in trillions of dollars. So 1.8 trillion, 1.3 trillion. So as I increase the GDP, what do you predict is going to happen with their CO2 emissions? Probably going to increase as well, right? That's our expectation. Okay, did that actually happen?
Yeah.
My R value is positive. Yeah. My R value is positive, and it's a pretty strong correlation, right? Not super strong, but pretty strong. 0.8736. R value is 0.8736. In terms of my table 11, how many degrees of freedom would I have? 8. Remember, it's n minus 2. Yeah, because we got 2 sets of data. Yeah. In terms of my table 11, at both the alpha 0.05 and the alpha 0.01 level, this is significant. The alpha 0.05 level is 0.707, and the alpha 0.01 level is 0.834. So at both levels, this is significant. Yeah. So you do n minus 2 for degrees of freedom for this, and then you say I only have alpha 0.01 and alpha 0.05. So basically, 8 at alpha 0.05, 0.707. Anything bigger than a 0.707 is statistically significant at the 0.05 level. Anything at the 0.01 level, anything bigger than 0.834 is significant. So we can say for both levels here that we have in our table, we are 95 and 99% confident that this R value is significant, right? So we're saying, okay, there is a significant correlation between GDP and CO2 emissions. Now the equation is y is equal to, or y hat is equal to mx, so A in this case is m, 199.535 x plus 56.036. There's my line of best fit. There's my line of best fit. And then I have to answer some questions. Use this equation to predict the expected carbon dioxide emission for the following GDPs. 1.2 trillion, 2 trillion, and 2.6 trillion. Okay. So say we had a 1.2 trillion GDP. Okay, I would go in and say 199.535, and that's an X value, correct? 0.535 times 1.2 plus 56.036. 295.478. 295.478. So I can expect the carbon dioxide emissions to be 295.478 million metric tons. Whoa, got louder there. Now, I could run this by hand, but I think it's a little bit easier to put it in your calculator, okay? I think it's a little bit easier to put it in your calculator, as long as you know how to get to it. Follow along, because this is always the tricky part. People always screw this part up. Again, there's something that you probably learned in your Algebra 2 class. If you go into y equals, And instead of hitting stat, hit vars. Stands for variable statistics. It's diagonally down and to the right from the stat button. Vars right here. And then you see choice 5, statistics. I'll scroll down and hit that. Go right twice to EQ. And actually, what's interesting here, you see some other options. SX, sum of your x's. Sigma x, standard deviation of your x's. Mean of your y's, sum of your y's, standard deviation of your y's. Scroll right twice to EQ and you see regression equation. Regression equation. Hit enter on that and you have your regression equation in there. And your y equals. Now, to see the scatter plot and everything, I'm going to zoom stat. And, oops, I did not turn on the stat plot. Now I'm going to hit zoom stat. There we go. Again, you got to have your stat, your plot 1 highlighted. Now, from here, it's super easy to find any x value. Or excuse me, to find a y value, give it an x value. Like, for example, I want $2 trillion. Okay, 2 is an x value, right? Second, calculate the value at 2. Done. 455.105. 455.105. Calculate the y value in x is 2.6 trillion. So second, calculate, come on, the value at 2.6. 574.826. 574.826. And what we can even do now is if I were to give you a y value, you could find an x value. For example, what if I knew the CO2 emissions of a particular country was, let me go something in here, 400. I know the CO2 emissions is 400. What do I predict their GDP to be? Well, I could go in here and say y equals 400. I know their CO2 emissions is 400. Let's predict that country's GDP. Where do I click? The intersection point. Second, calculate intersect. And then I've got to answer first curve, second curve, guess. I hit enter, enter, enter. I can predict the GDP to be $1.72 trillion. That's my paycheck. Questions about that? Feel good about that? We'll do this example tomorrow by hand. Sound good? All right, let's do that. There is your homework. You can use your calculator on this. All 3 problems. Don't go crazy. I'm gonna turn off the video.
Like the A, B, C, D, E, F, G.